Hi and a very good day to Dr. Leong. We are from Group 3 MTH3003 Statistics for Applied Science. We are going to discuss on how we get the answer for SCL1. These are my group members. So for question A, me and Najiba will present on how we get the answers. The question asks us to obtain the class boundaries, midpoint, and cumulative frequencies. Hence, draw a histogram and comment on the distribution of the data. So, in the slide, you can see the answers for class boundary, midpoint frequency, and cumulative frequency. So, firstly, you have to make a table and you put the info that are already given in the question, which are the marks, which is the class interval and the frequencies. And you add a column for class boundary, midpoint, relative frequency, and cumulative frequency. Okay, for the next slide, I'm going to show you some example on how you get the calculation. So for class boundary, for example, you want to get the class boundary from class interval 40 to 49, you have to add the lower limit from the class interval before, which is 39, and plus with the upper limit from class interval that you want, which is 40, and divide it with 2 and you will get 39.5. Okay, for the midpoint, for class interval 40 to 49, you just add both value and divide it with 2 and you will get the answer, which is 44.5. Next, for the cumulative frequency, for class interval 30 to 39, the cumulative frequency is 2. Meanwhile, for class interval 40 to 49, the cumulative frequency is the frequency from class interval before, which is 2, and plus with the frequency from the class interval that you want, which is 3. So 2 plus 3, the answer is 5. For relative frequency, you can get it by divide the frequency with the total frequency. So for class interval 40 to 49, the frequency is 3, meanwhile the total frequency is 30. So you divide 3 with 30, you will get 0.1. Last but not least is the relative cumulative frequency. So you will get the answer by divide the cumulative frequency with the total frequency. So for class interval 40 to 49, the cumulative frequency is 5 and you divide the value with total frequency, which is 30. So 5 divided with 30, you will get 0.17. So that's all for the calculation. So for the histogram part, I'll pass this presentation to Najiba.
Thank you, Alisha. So I will continue for the histogram part. So the x-axis for the histogram is the class boundary, and the y-axis for the histogram is the relative frequency. So based on the plotted histogram, we can see that the shape of the histogram is skewed right, and there is no outlier. So that is all from me. I'll hand over this presentation to the next presenter, Akmal.
Assalamualaikum and good morning everyone. Now for question B, they asked for median, mean and mode. First thing we have to look at is whether our data is grouped or ungrouped. And since our data is grouped, we'll follow with the formula below. Now to find the mean, we first have to find the total of the frequency times midpoint and then divide it with the cumulative frequency. And we'll get 60.5. Next, moving on to the median, we first have to divide our cumulative frequency, which is 30, by 2, and we'll get 15. Now, we have to find the class this 15th person sits in, which is 49.5 and 59.5. After we know that, we'll just plug in the value based on the formula. The formula given is Lm plus delta F over 2 minus cumulative frequency divided by frequency of median times the class range. Now, cumulative frequency over 2, it's 15, we just did that before, and cumulative frequency of class before is 5 based on the table, and FM means frequency of median, all of those times with the range. Range means that we have to minus 59.5 with 49.5. Moving on to the mode. Based on the table, we should know what class has the most frequency, and again it's the 49.5 to 59.5. And based on that, we just plug in the formula Now, LM again is lower limit plus delta 1 over delta 1 minus delta 2 times with C. Now, delta 1 is just the frequency of mode minus the frequency of the class before it, which means our frequency of mode is 10 minus the frequency of the class before it, which is 3. 10 minus 3 equals 7. And now delta 2 is 10 minus the frequency of class after it, which is 8. 10 minus 8 equals 2. And plug in the value in the formula, and now we'll get 57.28. That's all from me.
Okay, so hi everyone, my name is Aina and I'll be explaining question C. So for question C, we have to obtain the variance and standard deviation. Based on the standard deviation value, what can you conclude about the student's scores? So for this question, we have to find the variance and standard deviation. And to find the standard deviation, we have to find the variance first. So to do that, we have to draw a table and add additional 2 columns, which is fx and fx squared, where f stands for frequency and x stands for midpoint. This is because those 2 columns will be used in the equation of variance. So to find fx, we just multiply frequency with midpoint, and fx squared we multiply frequency with midpoint squared. And we do the same thing for the rest of the rows. And at the bottom of the columns, we sum them up because we're going to use the total values for the equation. And you also total up the frequency as well. And then we're just going to put all of the values inside the variance equation. So the variance equation is on the upper left, which is s squared equals to total fx squared minus total fx squared over n divided by n minus 1. And then we just put all the data in, and the answer is 176.55. And then to find the standard deviation, we just square root the variance, and we got 13.29. So to conclude, I calculated the correlation of variation, where I divided the standard deviation with the mean of the data and got 0.22. This is just to see where the standard deviation is located. And the conclusion is the standard deviation shows that the data are closely clustered around the mean. So that's all for my part. Now I'll pass to the next presenter, Nureen.
Hello, today I would like to present the SCL assignment, and my question is question D. Question D is find the 80th percentile and interpret its value. So to tackle this question, first of all, we have to use the K equals to N times P over 100 formula. So N is the number of observations and times P, which is percentile, and in this case it's 80 over 100. And then from this we can see K equals to 30 times 80 over 100. And that equals to 24. So then you look at the cumulative frequency in the table that you've done, and in this we can see that 24 lies at the 27th cumulative frequency, which is at the 5th class. So from this, we have to use the 5th class info in order to find the true value of the 80th percentile, because 24 is only the position of the 80th percentile, not the true value of it. So to find the actual value of the 80th percentile, first of all, you have to use the formula, which is SP equals to LBCP plus K minus CFB over FP times by L. So LBC is the lower boundary of the percentile class, which in this case is the 5th class. So the 5th class lower boundary is 69.5, and then we have to plus with K. K, we already found the answer, which is 24, times CFB, which is the cumulative frequency of the class before it. So since the cumulative frequency was 27 in the table, the before is 23. So the value of CFB is 23. And then we have to divide that by FP. FP is the frequency of the percentile class itself, and in this situation, it is 4. Now don't take the frequency, don't take the cumulative frequency, take the frequency itself of the 5th class. And then we have to times it by 10, which is the class width. And all of that is 72. And so 72 is the true value of the 80th percentile. And the interpretation of this is students who achieved a mark higher or equal than 72 scored better than 80% of the other college students. That's all from me. Thank you.
I will continue with question E. Question E, construct a board plot for the data if the minimum mark is 34 and the maximum mark is 87, and comment if there is an outlier in the data. So we will using formula like this. So calculation formula Q1 lower quartile is Q1 equal to L plus bracket K divide 4 subtract FE divide FA bracket multiply H, and we will count out the answer as in the picture. Next, we will continue with the median and Q3 upper quartile calculation formula. So, calculation formula median is median equal to L plus bracket 1 divide 2K subtract FE divide FA bracket multiply H. And lastly, for calculation formula Q3 upper quartile is Q3 equal to L plus bracket 3 divide 4K subtract FE divide FE bracket multiply H, and we will be able to see the answer in the given as follow.
Thank you, Firdaus. So I will continue for the box plot part. So box plot is used to describe the shape of the data distribution and to detect the outliers. So to construct box plot, we need to calculate Q1, median, and Q3. And to detect the outliers, we have to calculate the lower fence and the upper fence. So first thing first, to calculate the lower fence and the upper fence, we need to calculate the interquartile range. So for the interquartile range, the formula is Q3 minus Q1. So the answer for the interquartile range is 16.875. Next, to calculate the lower fence, the formula is Q1 minus 1.5 times interquartile range. And the answer for the lower fence is 26.69. As for the upper fence, the formula is Q3 plus 1.5 times interquartile range. And the answer for the upper fence is 94.19. Since Q1, median, Q3, upper fence, and lower fence are calculated, we can start to construct the box plot. First, draw a horizontal line to represent the scale of the measurement. Second, draw a box using Q1, median, and Q3 and mark the upper fence and lower fence. Next, Draw whiskers connecting to the given maximum mark, which is 87, and the given smallest mark, which is 34. So, based on the constructed box plot, as you can see in the slide, it shows that the median line left of the center and long right whisker, which indicates that the shape of the data distribution is skewed right. Also, there are no outliers.